Good afternoon, everyone.
Hello.
So today will be just like a recitation. If you have any questions from your lecture, you can ask me, feel free to ask me. And if you have any concerns about the lab report, also you can just ask me. That's basically the purpose for today. Alex, what's your question?
I'll figure I'd just unmute myself as that'll be easier. As you know, I already did submit my lab report, but I didn't see until just a little while ago that you were wanting us to do 3 graphs with for the different slopes as opposed to using the different sizes to connect the slopes for the graphs. So can I amend my report to have the 3 graphs, and then that way?
Yeah, you can
okay.
resubmit. Yes.
I can resubmit. Okay, perfect. Then I'll do that.
Okay.
I actually had the same question about that because I just saw that as well about the 3 graphs. I did the same thing that he did. Are you going to open it up at some point today that we?
I will maybe grading. I'll be grading your lab reports. Let me see. Today is Tuesday. Maybe tomorrow, or.
Okay. So is it open for a second submission? Because yeah, like I said, I just saw the graphs thing today as well.
Yeah, you can. I think I already modified to multiple submissions.
Okay.
So you can definitely do that. Yeah.
And you'll just grade the most recent one submitted.
Mm-hmm.
Got it.
Yeah. If you have concerns or questions for your lecture, we can definitely work on some homework problems or any similar problem that help you to understand the basic of physics. So, Vincent, you have a question?
Yeah, you're talking about for the regular lecture material.
Yeah.
Yeah, it's just, I mean, I would just, if there's any way we could go over just some more examples of the type stuff, because we've only done like 2 in class. We got 3 questions from. I just kind of want to know what to expect. Like, I feel like I feel pretty confident that I understand it, but I'm not exactly 100% sure yet as to what I should be understanding because we've only done so few.
Okay. I think I got your. Oh, okay. Any other before we start? I want to ask anyone else who has a question for the lab report.
Yeah, I have a question. The graphs, right?
Yeah.
So I did the same thing with the 1 graph because I was kind of confused with like the 3 graphs. Wasn't it supposed to be like a straight line?
Yeah, it's supposed to be.
Yeah, but
so
when I graph it, it's not a straight line. So it was like until I found the average of the 3, and then I had a separate graph. That's when I got a straight line.
Okay, so I see why some students get confused. I ask you to measure 3 times, and you also take an average. So what I mean by that is you take the original point, and then you measure 3. You have 3 extra points with the diameters and the circumference. So basically, you can land up it's so basically you have 3 points that's close, but also you have the original point with 0, 0. So basically you have a straight line with a slope. The slope is a pi. But because I didn't mention you have to plot 0, 0. So some students give me a straight line. Sometimes because it varies for the 3 points. Sometimes it's like a straight line, or sometimes it's like a curve. But when you plot the original point 0, 0, then you're supposed to get a line a linear graph. I can share my screen so we can have a better understanding about what I'm talking about. Okay, so Just a minute. Okay, I think you can see. So, okay. What I mean is like when you do the graph, this is X, this is Y, and I want you get 3 points. So basically, let's say one is 10, one is 10, 20, or 11, 19, or 10.5, 20. Let's say this is the 3 point you measured. So what I mean by that is like you have a 0 point, and then you pull out this 3. Let's say this is 10, 10, 20, let's say here, and another
So
point.
that means the graph's supposed to start from the origin then. So the origin
Yeah.
supposed to be a plot.
Yeah,
Or
so
one
you
of the
basically,
points.
right, correct. So
Okay,
you
I got it.
basically plot those 3. This 3 is like after you plot this, you still get like a linear, like there's a slope. So like some students give me a graph that like it's like this is 10.
Yeah, that is what
Yeah,
I
so
was
it's like,
getting to. Yeah, that's
so
what I
like
was getting, but
exactly.
I was confused because I said that makes no sense. So I said when I did the average of all the 3 and then graph that one, then I got a straight line and then said probably, oh, that's the way we're supposed to do it. So I was graphing them 3 first and I was getting confused. So I didn't do it. I just do the average.
I guess that's miscommunication. I only focus on like I just want you make sure you plot these 3 points here, and I didn't like know you just plot 3 points like without the initial the original point. But,
Okay, so I will fix that. Right.
all right, yeah. Any more questions for the lab report?
I just want to clarify, just so I am 100% sure. So you want per object, you want one graph with all 3 measurements as well as the average for that object.
Yes.
In one graph, and then object 2, all 3 measurements, the average. Object 3, all 3 measurements, the average. And those are the 3 graphs.
Yes. So for some questions, for some students ask me how to plot this. I feel like it's hard to explain to them, so I ask them to plot the average. So like if you take the average of this, let's say I didn't calculate, just like a 10.5, maybe 20. So you can also plot like a graph 0 and 10, 10, 5, and 20. Let's say the point is here. You can also plot with the average.
So
like yeah,
that makes sense. So we don't need to plot all 3 of the measurements on there, just the origin and then the average, and make that so yeah. Object 1 origin average, object 2 origin average. Okay, that makes sense.
Yeah, it should work too. Like
yeah.
It basically give you the same idea.
Okay, thank you.
If there's no,
I have a question. So in the lab report, do you want the table for these measurements to have 3 measurements for each object, or just the average?
Either way, like which way works best for you.
Okay.
Yeah, you can just take an average. You plot 1 is original point 0, 0. Let's say 0, 0, and you also like take an average. Let's say this is the average. Oh, sorry. Can you see? Then you can plot this one, or you can plot like okay. So here it doesn't like look like a So let's say if you plot 3 points, it may be like this. So, but like I think like when you look very because like it's not the number. I hear the number. I just made them up. It's not so small. But if you like from your measurement, it's like 1,000, 2,000 kilometers. So it's basically what you look at when you look at your graph. It's basically like this, and there are 3 points. It's like a line. It's not like you have multiple curves, because here the number I give you, I made up the number here is like very small. But if you include like a very big number from your measurements, it should be looking at like a linear graph, a line. So you guys get what I'm saying?
Yes, it makes sense.
Yeah, thank you.
Okay. Let me see the chat. Okay. Yeah, one graph per object. So I can say like a you measure different object, you have like maybe a different value of pi, but the pi value are pretty close to 3.14. So that's the purpose. Okay. Any more questions? So so today this like a session of the lab is not required because as we discussed last time, we will be meeting next Tuesday. So if you don't have any questions, you can stay for more questions, or I mean, like we will work on some like homework or practice, and also you can like feel free to leave work on your like lab report. Yeah. So if there's no more questions for the lab report, so we can definitely work on the homework, the problems. Okay, who wants to go first? Sorry, my nose is too. I also posted the video of a recording on YouTube, but it's unlisted. So anyone who has a link could only those who has a link can get access to the recording. So if you are not comfortable with that, you can just let me know and maybe delete it later. And also from next time, I'll just pin my video on the top on the screen. So like if anybody say watch our video, they wouldn't see you like on the screen. So, but if anything that makes you uncomfortable, also please let me know. So we're gonna work on those problems from your lecture. So let's see, I have a textbook here. Any questions here so far? Okay, no more questions.
Yeah. I have some questions like but I'm trying to work on the lab too, but so I don't want to be doing two things at once because I just was correcting the graphs. But I was looking on some constant acceleration problems in the textbook and stuff. So I was realizing that the concepts that we learn in class, we have to do much more on these type of questions. So for example, the homework question, like accelerating and deaccelerating, and then figuring out the time used.
Okay.
It's not as straightforward as how he teaches it in class.
Okay, I definitely can help you with that. So like anyone want to bring a question? We start with a question, like just
Yeah, give me a second. Let me get the textbook.
I think I have a textbook.
Okay. I got it. Okay. All right. Okay, here's one. Right?
I mean,
you have the textbook, right?
Yes, I think the fundamentals of physics 11.
Yeah.
Right?
Yeah. So number
You
40.
make homework.
Hmm?
Number, like which page? Can you tell me the page?
Page 34.
34.
Phillips. Yeah, that mean I it too. Mean them a play the right them just right now watch
It's a little bit slow.
Phillips Long Island. Okay. Who use in the Grand Slam get lick out the whole of them gone in there. Challenge the team at the Grand Slam. And she get lick out.
So it's like on my Google Drive. It's 35. Is that 35? 30.
Yeah, with the motion along a straight line, chapter 2, those.
Okay, let me see. Someone is here.
Number 40.
Okay, I'm sure.
Six of them one after them. Everybody can clear to go on to the big tennis then.
Okay.
Miami have a big
40
one
then.
start next month. And Miami have and California.
Okay, so what's your question?
Number 40, like I'm just saying,
Wait,
how would you
Are
approach
you seeing the page number or you are asking the question number?
the question number? It's on page 34 of the textbook.
34. Oh, okay. Okay.
I don't want them in them big projects. And I said with them, 5 them and US. Watch them more.
Okay, number 40. You're driving towards a traffic signal. When it turns yellow, your speed is legal speed limit V0. That's the acceleration rate. Okay, your best reaction time to begin braking. Okay, to avoid the front your car, enter the intersection after light turns. Okay, why don't you just tell me what are your like ideas about this one, so we
I would
can.
say use the so for number 1 it says to avoid having the front of your car enter the intersection after the light turns red, should you brake to a stop or continue to move 55 km/h if the distance to the intersection and duration of the yellow light are 40 meters and 22.8 seconds? And so I was thinking like use the formula V equals to initial velocity plus acceleration times time to
You
find
were thinking about, sorry. Oh, what you were thinking about?
use the formula the final velocity formula to find, so V equal to initial velocity plus the acceleration times the change in time.
So like
To
what's the,
find,
yes, I think that's right. You're using, I tell you, you're using the right formula here. V, so VT equal V0 plus AT, right? So
yeah.
yeah, so like you're trying to calculating the speed, and also like you have to consider the distance as well. You know why?
Hmm?
The distance.
Yeah, because what I do is when I look on the questions, I don't know if this is the right way to approach it, but I look on like what's missing in the question so I know which formula I should use. But sometimes it's more complicated than that.
Yeah, I mean, like let's just try to like break down into small portions. We try to understand the question first. So there are 2 questions. One is like let's say one is for the distance 40 meters and the red light is 2.8 seconds. You have to wait 2.8 seconds. And another is 32 meters and you have a red light for 1.8 seconds. So like it's basically the same. They're asking you the same question, and we try to work on the first one. Then you can like also other students can try to work on the second one. So basically that's the idea.
Them job people to move in the movie where you hear them come down in you want to see.
Okay, I think that's fine.
Them wicked
So okay, so well, I read. So basically, when for me, when I do a question, I read the I read the text and I try to make it like a more straightforward to me to understand. Maybe Shaver, you can like mute yourself.
Oh, sorry.
Thank you. So like when I try to draw a very simple like a plot, I can understand the question better. So it will like simplify the question. So you see, when you saw a question, there are so many words, you don't know where's the useful information and how to correlate them. So it's like very messy and like massive information. You have to learn how to make it very straightforward. So so first there's a like a let's draw like a line. So basically you are here, and this is the intersection. And you don't want to hit the car. So before you let me try to make sure. So maybe I just turn off my camera. So you have your original speed V0. So here's V0. It's 55 kilometer per hour. So you see here okay, so we want to simplify everything. So like there's the initial velocity, and there deceleration speed, and the reaction time, and everything. So first of all, we want to unify the time. So like so here is meter per square second, and this second. So there are kilometers and hour. We want to convert to meter per second. If I don't remember wrong, it's 55 divided 3.6 is meter per second. Am I right? Or I have to time? So you guys are following me?
Yes.
Okay, let me double check. Kilometer per hour to wait a second. Divided the speed value by 3.6. So yeah, just remember every time you want to convert the kilometer per hour to meter per second, you just divide it by 0.6. So you always remember that. So you don't have to do like a kilometer to meter or hour to second. It's so much. We just want to make it everything like a simple to us. We don't want to spend too much energy like a so when in the exam or in a real life, you want to focus on your energy and time to the most important part, not just like the unit conversion. So you do everything at the beginning. You make sure everything was unified, and you have the same unit, and then you can like focus on your question. So any questions so far? We convert the kilometer per hour to the meter per second.
No, we can continue.
Okay, so yeah, so basically we have the initial speed. Okay, we have the initial speed. So you are here. This is you, and this is the intersection, and the deceleration speed, and this is your reaction time. Let me see the textbook. Here's the textbook. So your reaction time. So what is the reaction time? Reaction time is like when you want to do something, you have to like really realize what is going on. So basically, they tell you you have this time to keep your current speed because you haven't realized what is happening. So let's just say S1. So let's say this is the total. The distance is for the first question is 14 meters, right? Wait, it's 14 meters. But there's like a reaction distance. So basically, during this time, you are still like like driving with your constant speed, which is 55 divided by 3.6. So you have the speed. So this is a meter per second. So basically, this S1 equal to V0t, right? So basically, you have this like a distance you like riding with your constant speed, and then you want to decelerate. Then you realize, oh, there's a red light. You want to stop, right? So anybody is following. So everybody is following me here. If you didn't like, maybe sometimes I speak too fast, or sometimes I miss the connections. When for the like for you it doesn't make sense to you, just stop me, okay? I just assume everybody is following me. So here's the S1, and then we try to calculate the S1. S1 is VT. The V is initial speed, and the T is your reaction time, obviously. And then basically you are starting from here. So let's say the here is this point A, and you start to decelerate at the point B. So basically, this is the distance you wanna do the deceleration. So here's like a very then it turns to a very a pure math question. So basically, this is S2, and let me see. Okay, you remember this graph, or we can draw here. Like, we can write down here. So like you now so the total so you just make like on your scratch paper, you just make sure everything is clear to you. As the total distance is S1 plus S2, S1 equal to V0t. So this basically your reaction time. You're riding with your constant speed, and also you know this one. You can solve this one. You have to figure out. You can also solve S2. So S2 equal to S minus S1. And why we need to know S2? So S2 is basically it's Vt plus half AT squared. So here, because you are deceleration, so A equal to minus 5.18. Well, I cannot move. The unit is here. So basically, you take everything in. Like, so here is T1, then we say T2. Basically, from A to B, you have everything marked as one, S1, T1, and from B to the end C, then you have everything marked as 2. Like this is S2, and you have T2. So basically, you try to calculate so like so for now, we have two ways to solve the question. One is you try to calculate if you are using so what's the time for the red light? It's 2.8 seconds. So like when you are at a point A, you have a 2.8 second. But after your reaction time, how long is your reaction time? 0.75 seconds. So basically, they want you T2. They want you have 2.8 second minus 0.75 second. This is the time you have this time to ride to like say if you can like stop before the intersection. And so basically now you have two ways to calculate. One is you use this time to take this T2 into, okay, this is to this equation. Say if S2 is smaller than if the calculated S2 is smaller than the S2 you get here. If that is smaller, that means you are okay. You can stop before the red light. But if your calculation, so if you use this T2 into this one, into let's say, okay, this equation 1, we call equation 1. If you take T2 into equation 1, then you get S2 is bigger, is greater than the S2 you calculate here. You calculate here. So this is okay. Why don't we call it S2 prime? So if S2 prime is greater than S2, so S2 you can calculate here. This is the S2 prime. And if it's great, if S2 prime is bigger, that means you need more time to stop before the red light, right? Like basically you will pass, like you fully stop, you'll be there, like because here here is S2, and then if S2 prime is bigger than S2, so you have to pass the intersection to stop, to fully stop. So basically, let's give you a hint, like how to compare, how to judge if you can if you needed to stop. Okay, so should you brake to stop or continue to move? Okay, I think I understand in another way, but apparently the question here is more simple here. So they asked you, do you need to stop or you can continue with 55 kilometer per hour? So you basically, you can, they didn't ask you compare those distance. You just try to you just try to get this, calculate this S2 prime, and it should be smaller, smaller than S2. And then they also ask you if you're moving with 55 kilometer, then you is that okay if you're moving at a 55 kilometer per hour? So like basically this one, in this case, you can just do two separate calculations. If you were riding with 55 kilometer per hour, you just use a full distance. Full distance 40 kilometers. Full 40 meters. So this is the distance, 40 meters. And the speed is 55 divided by 3.6 meters per second. So you basically try to calculate the time. If the time, let's say 40 divided 55 divided by 3.6. So this is the time. If this time is smaller, it is smaller than the red light time, 2.8, then you'll be fine. So you can just ride with your normal speed, because by the time you got to the intersection, the red light turned to green. So you basically compare the time. So here, okay, any questions? I feel maybe I didn't explain very well.
Yeah, I understand the second part in terms of the just finding the time and then comparing it, but with the thing that you were explaining with S2 prime and then S2 got me a little bit confused, because
Okay.
we're supposed to have a reference point and then another point, and then we're
Yes,
supposed
actually,
to take into consideration what's happening in between those 2 points. So that's what's confusing me when you add another point and then
sorry. I think at first what my understanding is like try to calculate if he can pass. So like, any question, Vincent?
I mean, the second portion gave us the answer, right? Because if you take the 40 meters and you divide it by 55 over 3.6, you get 2.6 seconds, which is less than the time it takes for turn red. So you would pass red.
You pass.
It's as simple as that.
Right. So, okay. So actually, like this question is more like much simple. Like I at first I thought like maybe they ask you compare this. Okay, you cannot see my pen, but okay, let's try this. At first, I thought that they want to ask you to compare this one, try to calculate like more sophisticated. Like let's say they already assume you stop, but actually the question just asks you if they need to stop, need to brake. So basically, yeah. So first question, you have to calculate if you are riding with your 55 kilometer per hour, how long it takes to get you to the intersection. This is the first question. So you calculate, okay, you get, Winsor, you got the answer 2.6?
Yeah, it's 2.618, but yeah.
Okay, so basically, if you are riding with your 55 kilometer per hour, by the time you got you from A to C, then you will only takes 2.6 a second. But the red light is wait, the yellow light. Yellow light is 2.8 seconds. So you have plenty of time to get there. So you're okay. So the second question, they give you 1.8 second. So by the time you by the time it turns to the yellow light, the red light. Sorry, I'm confused. So by the time, so they only give you 1.6 seconds to turn yellow to red. So you have to stop there, and you have to make sure you stop before the red light. So then in this case, your A, say B. So basically, you're try to like magnify this 1.6 second. So basically, you have the T1, your reaction time, and there's T2. T2 is your like total the yellow time. Let's say is T. Then T minus T1. This is your T2, right? And then you have this like a distance S1 and S2. So what you want to do is you stop before this before the red light, and S2 equal to VT plus a half AT square. So A is minus because your deceleration 5.18 meter per square second. So you can take the time here T2 to this equation. We call it equation 1. Then you can get a S2. Like this, basically, I can tell you the S2 is definitely smaller than okay, we call it prime S2 that S minus S1, because you can definitely stop before the red light. So any questions for now? Later I'll explain what I was thinking before here. So like Shaver, you understand? You're following me?
Yes, I'm following you.
You have any questions? You think like now you have any questions for this problem?
No, but the question that I have is like for part B, it give you a different distance, right? So that would be S2.
Yes.
And then
okay, we see. Okay, so we draw. This is the from A to C is the distance. So basically here, if we change the whole distance, you just change the S to 32.
yes, so it's basically doing the same thing, finding the time and then compare it to the 1.8 seconds.
Yes.
Yeah, I understand.
You want me like work with you together, or you have any questions? I mean, just make sure you understand.
Yeah. In fact, I would like to go over like the Holberg problem on number 59. See how you
59.
like.
Okay, I just want to make sure anybody else like have a question for this problem. Because like at the beginning, I made a small mistake. I thought it's more complicated. But actually the question was, I hope I didn't mislead you to give you more confusions when we are working on here. But the question seems like they are more straightforward here. They ask you if he can continue with his current speed, or he has to stop, right? I hope I didn't confuse you. So if you want like should I start like a, okay, I just want to summarize a little bit for this question. So basically, okay, let's draw, okay, this color is okay. Okay, 50, now we will do question number 59 later. I just want to summarize, I don't bring more confusions to you. So basically, you are riding your bike, right? So here's the intersection, and there's the yellow is there's a yellow light, and you have to stop when it turns to red. So so basically this is the idea. So let's say this distance is s, and so like even there are two questions. They give you one s is 40 meters, and another s is 32 meters. But it doesn't matter. You have to understand the general picture. What is s? So you can always put different numbers to s, but you make sure s represents this distance, right? So the question they're asking you is like, with the initial speed of 50 kilometers per hour, well, you divided the, anybody tell me the their quick calculation for 55 divided 0.6? Okay, I do math.
It's 15.28 approximately.
15.28.
Yep.
Okay, so this is the speed, initial speed. Yeah, so basically you were writing this with this speed, and first you want to check if you can wait. So if you can write this speed while you're wait, I think
So Professor,
yes.
Yeah, it's
The-
coming in at the same thing. In the same thing that Django.
The light turns right. So the light is now the light is yellow. Okay.
all right. So to simplify, right?
Yeah.
The initial velocity between position 1 to position 2 is 55. So the final velocity will have to be 0 because you're approaching the stoplight. So eventually you have to stop, right?
So your let me try to understand. So at first your light is
55.
Yeah.
That's what you're driving, that your constant velocity, initial velocity, right? And then you're going to a stoplight at the intersection, so you have to stop. So the velocity will slow down until it reaches 0, right? So the final velocity would be 0. And the acceleration is constant, so you're traveling at 5.18, right?
yeah, so we try to understand the question correctly. We can understand together. So like at this point, the light is yellow, and you want to stop before yellow turns right. Right?
Yes.
So then why they ask you to continue with the current speed? Should you brake to stop or continue to move if the distance to the intersection? But I don't think they will ask you. So you have to stop because the red light, you have to stop to make your speed is 0. It's not like a red light turn to green. At first I saw the red light turn to green and then white turns to red. Okay, so we have to make sure everyone is on the same page. So when you are at a point, the traffic light is yellow, and you want to stop at the red light. So you want to make sure your speed is 0 by the end of this, before you enter the intersection, right? Let's see. Am I, so do I understand correctly? I'm so confused now. Okay.
You wanna start over the question? Like
Okay.
it's
So basically we're like so we are here and we now it's yellow and we want to make sure we stop before the red light.
yeah, so that means you're slowing down, basically.
Yeah, you're slowing
So
down. The
it's
white
like, so it says your best reaction time to begin braking is capital T equal to 0.75 seconds. Right?
Yeah. So
And then to avoid having the front of the car enter the intersection after the light turns red, should you brake to stop or continue to move at 55 kilometers per hour? So if
you're
this,
gonna stop anyways. So do you mean
yeah,
that?
so the final velocity we know is already 0, right? So
you have to stop. So basically you have to stop anyways because it's red light.
yeah,
So,
and then it say you should you stop or continue? So you're supposed to stop, right?
yeah.
And then if the distance to the intersection and the duration of the yellow light are 40 meters per second, 40 meters and 2.8 seconds. So that means your distance from the light is 40 meters, right?
Yes.
And
So
then
this is 40 meters.
and the light lasts for 2.8 seconds. That's how long the yellow light will be up for,
Yes.
basically, till it changes to red. And
T
then
is 2.8.
yeah. And then it says your reaction time to begin braking is 0.75. That's your reaction time. So
Yeah.
that's when you see the light change to yellow, basically.
Yes. So
right?
like, yes. So this is basically this is S1. S1 you have S1 equal to VT, V1 T1. V1 is 15.28 meters per second, and your reaction time is you're riding constantly. So basically you can calculate S1. And then you have the whole distance. Now you have S2. This is from B to C is your distance S2. And you have your so this is what I originally understand. So you basically have the time, and you have to calculate the distance. You have to make sure you stop before the red light. So basically, there are two ways. You can just do the let's say you're trying to let's just focus on one. So this is T2. T2 is like your the total yellow light is 2.8 T minus T1. This is the time you can ride to stop to make your speed to 0. And so this is the maximum time, right? And also you have like a V2 equal to V plus 80. I cannot. So here, why I say that V2 equal to V plus 80. So V2 is, you have to make sure V2 equal to 0. So then you have a V1, this is the initial speed, 15.28 minus 5.18, this is the 8 and times T. So basically you have this one, this one, this one, and you can solve T. Let's say T3. So T3 is definitely smaller than T2 because you have, so this is the total, like the total, the maximum time. T2 is the maximum time you can use to stop to be 0 with a 0 speed. But here you can, if you have you already know your acceleration, a deceleration time, a deceleration speed, you can definitely control your speed to be 0 before it reach to the maximum speed. right?
Repeat that one more time.
So like which one? So T3 is definitely smaller than T2 because T2 is the maximum time you can react. You saw the yellow light, you want stop before it turns to red. So that's the maximum. Give you enough time. You can have like a smaller deceleration speed, but because the question already gave you a deceleration speed, so you can definitely use this deceleration speed, which is 5.18 meter per square second. You see here, this is your deceleration speed.
Yes, that is what I was asking you from the start. So you use V plus AT, and then you know that it's gonna slow down before it reaches 2.8 seconds. So
Yeah.
that would just be the answer, right? Instead, I have to take into consideration S1 and S2. You just focus on the velocity instead of the position.
Yeah. So like I think at first we all get confused about if they ask you if you need a break to stop or you move continuously.
Yes.
So I was thinking, oh, maybe after if you move smaller than the light, then the red light turns green. Actually, there's no like a green light, just yellow to red.
Yes.
You're gonna stop anyway.
Right. So that's what I'm saying. Like when we approach these questions, we look for things that's missing, right? And then just focus.
Right.
I try to apply formulas that we know doesn't contain like the missing quantity. That's like the trick to it.
Yes, you have to understand the question. It saves you more time. Like we spend like a half hour trying to.
Yeah, that's what I'm saying. So imagine me like trying to practice these questions and like what the hell is going on? Yeah. But yeah, even when I was doing the homework for number 59, that's why I want to go over it. Like it took me a long time to figure out what was happening. Like, how should I apply the question? Should get to the final answer basically. So that's why I want to just go over it.
Okay. So like let's say anyone has a question for 40. Question 40. Okay. Anika.
I actually have a different question. So I was just finishing up my lab and I have like many questions. Can I ask you now?
For the lab report?
Yes.
Yes, you can ask.
Okay, so for the part 2, we have to make graphs, right?
Yes.
Okay.
So I basically explained in this video, but I can answer one more time. So like any question, like okay, so I feel like I explained. Okay, so like the three data point, I asked you to plot. I forgot to tell you, you have to include the original point, so which is 0, 0. So after you include the original point, then you have like a linear line, like you will have a slope.
Okay.
Is that you are asking?
So
How
we have
to plot?
3 graphs for 3 objects, and then the table for just to show what we chose.
Yes.
Okay, Miss John, one more thing about the graph, right? I'm sorry.
I'm sorry.
Yes.
I will try to be quick.
So the slope will equal to the average of the circumference and the diameter, right? So should we just do the calculation like to show that the slope is equal to the average
You don't have to
circumference?
show, you just tell me what is the slope. Because you
Okay.
plot already have the slope.
Okay, all right.
Yeah,
Okay,
but
got it.
it basically is same. If you plot 3, like let's say you plot this is the original point and you have a 3 point. It's very close because it's very close. Then you plot, it will look like this, and you have like a 3.1 3, maybe x plus. Yeah.
Yeah, I did it. I did it a while ago, and then I got the straight line, so I know what I'm supposed to do now. So I was just asking if we need to show the average and the slope is the same thing.
Yeah, it is same thing. Like you can also like include the 3 points here, or you just take the average. That's 1 point. Basically,
Okay.
you include 0, 0, and your
Okay, all right, I got it. I'm just gonna like do the other question. So this is we're gonna have until tonight to resend it.
Yeah, you can like yeah, I set the time is 4, but as long as you submit by tonight, it should be fine. I wouldn't deduct from
Okay.
that from being because
Okay.
some. Okay,
Okay, I got
Anita, did I answer your question?
Yes, and I have another question,
Mm.
which is for part 3, the linear measurement. All we have to do is just to convert to centimeter, millimeter, right?
Yeah.
And at the end, the error in ruler, it's all in centimeter, right?
Yeah, you just show you can also put in the kilometer as long as you put the right unit. So I wouldn't charge for like a.
We need, oh yeah, okay.
You
Okay.
because they didn't give you the unit, you have to put it. You can choose which whatever unit you like as long as you put the unit. You just don't give me a number. You given me a number, I don't know what that means. It has no meaning.
Okay.
Mm.
Okay, I get it. Thank you.
Mhm.
We just need to put graphs for part 2. That's it.
Yes.
Oh, great. Thank you.
Mm-hmm. Okay. Uh, 59. Any more questions? Okay, let's look at 59. Water.
Professor, I think for the one that we've been working on, the number 40, I think it was number 40. It was I think I figured out how to do it. But it was yeah, it definitely took a while. Oh geez, sorry, the sun's right in my face. Let me reorient myself here. I mean, yeah, I looked it up because I was curious because I was like, I have no idea how we'd even go about that given what we've been given. And it seemed relatively straightforward. It said to use the formula, which we haven't been given yet in class, but it seems like it's the only way that we could have done it. So maybe this type of question wouldn't even be on what's called on an exam because, like I said, we haven't even been given this form, but it's the final velocity squared equals initial velocity squared plus 2 times acceleration times distance. And so yeah, so when you obviously you want the final velocity to be 0, and then initial velocity was the 55 over 3.6 squared, and then 2 times the acceleration, which is negative 5.18, and the distance would be 32 minus S1 because S1 that's how long that's the distance it takes you to react, right? S1 would be so it'd be the 0.75 the 0.75 what's it called seconds, and then so yeah, in 0.75 seconds you would travel 11.46 meters at that initial velocity, so you'd have 20.54 meters left to react, and then using that equation you get it to be at 0 speed. It takes 20.6 meters, so it wouldn't work. Does that make sense?
Okay. Well, what is like okay.
So it's so for the final velocity to be 0, it would take 20.6 meters for it to be 0, but you only have 20.5 meters to react because after the initial 0.75 seconds, you have 20.5 meters left until the light, and it takes you 20.6 meters to get to 0.
Okay, so like, what's your conclusion?
So it's actually neither, and that's it. Like that was the answer. Because for part B, so if it's the light is 32 meters away, and it takes 1.8 seconds to go from yellow to red. So from A to B is time T1 is point on the graph that you have right there. From A to B, T1 is 0.75, and S1 would be 11.46.
Okay.
from A to B, S1 would be, and so S2 from B to C is 32 minus 11.46, and you get 20.54.
4, 6. Okay, yeah. So yeah, this is the distance you're gonna like do the deceleration.
Yeah, and then in the and so then you could just plug it using all that. So it was given the formula, and I think this is why probably Shavar was having such a hard time with the two, because I was looking at it, I was like, I have no idea. I have no
You
idea.
haven't learned this equation yet?
No, that's at least from what I recall, and I feel that I've out of the other two people. guys
No, we learned like the two basic equations. So V
Yeah.
equal to initial
V equal to-
velocity plus AT, right?
Yep,
Okay.
And then the position formula, which is
exactly, and then it was S
X,
equals
yeah.
T plus 1/2
Yeah.
T squared.
So what I learned is that he's not gonna teach us how to like convert it into the other equations. We can use both of those equations to convert it into the rest of the equations. So for example,
So you were able to
if
solve part B using just those two?
yeah. So for example, the V squared, right?
Mhm.
All right. So what you would do is like, if you want to know that T is missing, right? So from equation 1, you would say like you subtract V, the final velocity from the initial velocity, and divide by the acceleration, right? And then plug it into the position formula to get the V squared formula, basically.
Okay, wait, sorry, I want to write that down because I'm actually curious. So you took so from V.
So
0.
yeah, so and then you find T, you convert that equation to find T, like you make T the subject of the formula, right? Time.
Okay, so you ended up obviously, so if you take T, you just did V minus V0 over A.
And then you plug it into the second formula anywhere you see T.
Let's okay, let me see.
And then you like figure out how to convert it to the final like formula, which is V squared minus V initial velocity squared over 2A. So that's how you get it, I think, that formula.
V0, so for the second formula, V0 T. So for T, you put V minus V0 over A plus
Yeah, so
A, and then for T again, V minus V0 over A squared. Let's see. I'm curious. That gives me the exact same result. So S equals for V0 is 55 over 3.6. V minus V0. So but V, because you want V to be 0, so it'd be 0 minus V0, right? So it'd be negative 55.36, right? I mean negative 55 over 3.6 over A, which is the negative 5.18 plus 1/2 negative 5.18 times oh wait, the whole thing squared. Hold on. 9 negative 8 squared. And that, yeah, okay, that does make sense. That does make sense. How did you know to solve for T out of that initial one?
So what I was saying was when you see certain question and then certain things are missing, right? Then you know that you can use like each of the formulas to, like, for example, time is missing and you want to find the position, and you're only given the velocity and the acceleration, then you can use that equation to convert it to solve for time and then plug it in. And then you know what the position is. And then now you can find what the velocity of like S2 is, because we only know what is for S1, you understand?
Yeah,
Yeah.
makes sense.
Let me try to think how we get it to derive from this.
So basically for this question, it would be like X1 would be 11 point whatever it was, right? And then the whole position would be like 40 meters. So you subtract that and then you like divide by the difference between the 2.8 and the 0.75, right? To get like the final velocity basically. And then you could find out if your time was actually faster or slower.
Yeah, that makes sense.
Yeah.
Wait, can you see my screen?
No, you can. So,
So basically, yeah. So you if you want to use this one, this direction, this equation, you can also derive it from like the equations you already know. So so here are the few questions that you have to remember, like very you have to be very familiar. One is like VT equal to V0 plus AT. Another is at S equal to VT plus half AT squared. And then the other one is VT squared minus V0 squared to AS. So how do you get derive from this, like how you get this equation? You basically, let me see, you basically take the previous, the equations you learned, and then you do the, like you replace to, like you basically just play with some equations. Let's say here how we do that. V0. So basically, if you take a Vt equal to V0 plus AT, you take this one, 1, 2, and this is 0. Okay, let's say we take a 1, 2, 2 equation. So basically, S equal to V0t plus, wait. Because here it doesn't have a t, so you have to like do an observation. So here you have V0, Vt, t, and a. So here you have V, S, and a. So there's no t. So the way you want to get rid of, you want to get this one is to like to use like everything to represent t. So let's say we use equation 1. So here is equation 1, and we want to say what t equals. So t equals Vt minus V0 divided by a, right? So this is the t. Then you take this t to the second equation, because we want to get rid of t. So we basically use, if we don't want anything, we just use other thing to represent this one. So like now from the first equation, from this one, we can get equation 3. This is our equation 3. And then we want to take equation 3 to equation 2. So basically s equal to vt plus at squared. And then you put the t here. So s equal to v times t, a vt minus v0, and plus half a t squared. So t squared is a vt minus v0 squared. So let's see. Okay, so these are two. You can just do the like the cancel lot. So because there are 2a, then there is 1a. You just have 1a left. Also, you have a 1a left on the on the bottom numerator. Then you can put you can take them back here. So basically, it's as equal to vt minus v0 plus half of vt minus v0 squared. And here you just want to make it like a clear. Okay, so you can times 2 on the both sides of the equation. So it's 2as equals 2vt minus v0 plus vt minus v0 squared, right? Because we times 2, like we times 2. If we times 2 here, then it's 1. We times 2 here, we times 2 here. If you just make sure like it equals still in the equation. Like if you time or divide it by anything, we just make sure that you do the same thing on the both sides of this equation sign. So then the whole the meaning wouldn't change, right?
Right.
Yes.
Yeah. So you basically like okay, it's very complex. 2as equal to 2vt vt minus 2v squared. Basically, this is the 0, right? And plus here's vt squared minus 2vt v0 plus v0 squared. So here you cancel, and now you have a 2v. This is 0, and you have 1. Basically, it's you can just have 1 left and a minus sign. So it's basically vt squared minus v0 squared. So 2as. So basically how you do the derivations. And if you so you're following me, you understand how I do the derivative, how to get this equation?
Yes, that makes, yeah.
Yes.
So basically you have anytime you don't need anything, or the problem didn't give you the time or the distance or speed that you need. You just try to play around with those equations to make sure you have other to represent the here the time you need. Okay, that's what I want to say for this equation. But either way works for there are many ways you can solve a same question. Yeah.
So like how we got that, can we just go over 59 and probably wrap up after that?
Okay, yeah, we just go over. Water drips from nozzle of a shower onto the floor. So basically I tell you what when I do a reader question, I just what I do for on my scratch paper. So 59. And water drip from nozzle of a shower onto the floor. 200 centimeters. So basically this is the shower, it's 200 centimeters. The drops fall at regular intervals. Okay, basically it dropped 1 by 1. Like after this one, then drop another one. Interval of time. The first drop striking the floor at the instant of force. Okay, so basically this is like after the first one touch the ground, then the fourth one begins to fall. When the first drop strikes, when the first strikes the floor, how far below the nasal? Okay, they want to ask you the second one, the second and the third. So basically, you understand the question. Okay, so here the water dripping from a shower to the ground, and when the first, because it drops like regularly at a like a equal equal interval of time. When the first one hits the ground and the fourth one starts to drop. So here there like we just wanna like make it simple before we dive into the question. So the height is 2 meters, right? We just convert, and then you know the gravity acceleration is 9.8, or you can. Did your professor told you use 10 or use 9.8 meter per second?
10. He
Okay.
said use 10 for this class. Yeah.
Okay, it's 10 meter per second, right? So square. The unit is 10 meter per second. So I'll double check. Gravity. Oh, it is a constant. Is that constant? Oh, it's a meter per. So this is a unit, because like when, you know, like we do the questions, we normally use a meter and a second. We don't use kilometer and the hour. So, but if they require you to do that, you can also always do the conversion by 3.6. So this is the G, and so basically you have, let me see. So you wanna, so basically this is the first one, the second, a third, and the fourth. And you wanna say the time intervals, because if you like, this is T1, and so let's say the time intervals is T1, and then you after 3 time intervals, then you have the whole distance, right? So let's see, which equation do I need to solve this one? I can use S equal to V0 t plus AT squared. So this is, let me see if I can use this one. You have the G, you need to find the T, but initial, and the initial speed is, initial is 0 because it starts dropping, it's 0. The S equal to the hat. So you can solve the total time. So basically here the time is for the whole, when the first drop from the beginning drop to the ground, this is the total time. But as you also know, like the first one, before the first one, when the first one hits the ground, the force starts to drop. So basically there, so this T equal to 1, 2, 3, 3 T1. So the T1 is the intervals, right? And what's your question? Ask you. So what's the height? So how far below the nasal? Like basically the second, they ask you the distance, this one, 2, and the distance this one. And if you know the T intervals, you can basically also calculate as, let's say D1 equal to, because the original speed is 0, AT squared. So you can just AT squared, and the D2 equal to AT AT squared, but the T here is 2T1, and the 3T1 equal to the time you calculate for the whole journey, the general journey, by using this one. Does it make sense?
Yes. Yes, it does make sense.
Okay. So what are you thinking before? Are you working on your question?
All right. When I was doing the question, right?
Yeah.
I wasn't like thinking of it during intervals. I was thinking of it like it's just a position in time. Like it's like if one drop is here, then the other drop is here. So I was thinking like the position between the two drops. That's how I was thinking about.
So like I think for you can every time you read a problem, you just try to draw to mimic the situation so you can understand the question better. Even like all the questions are from a real life question, but you can just make it simple, like draw a line and segment them, so it will make more it will make more sense to you, much sense to you, right?
Yeah.
Are you working on the question now?
No, I already did the question. I was just gonna clarify.
Okay.
Like, yeah.
All right. Yeah. So any questions? Any more questions?
So that's it. I just understand that. Like,
does it help?
Yeah, a little bit. Yeah, it does. But I'm just trying to get a general idea how to like approach different questions. I just using examples.
I also feel like I should, because when I see the question, I should like my brain is also processing, and then I get the idea and then write down. So I think maybe next time, like we can, if you have questions, you can just send me before, so I can look at them, and then so I could listen more to what you think, so I can like really target on like try to help you instead of like just myself writing.
Yes, so that sounds like a good idea because next week is a lab, so the other week.
The following
So
week, you send me the question before.
Yeah, I will do that. Definitely.
Okay. Yeah, so otherwise I just like write down myself.
Yeah. That's what I'll be doing when I'm trying to like practice these questions.
Yeah, I think if I know your if I prepare the question before, I know okay what's the strategy for each questions, and then you bring up your own like the way you are thinking, so I can be more like we can also work on like more specifically to help each other, right?
Right.
Instead of only me just write and I'm not sure even you guys are following me. That's kind of a little bit frustrating to me.
The beauty of physics, right? There's not one way to do a question. There's like 5 different ways to do one question. Yeah. So what I'm gonna do now is like I'm gonna try to correct the graph so I can send it in to you by tonight. And then that's it basically.
All right. Yeah. So yeah. Any other questions?
Well, for now, no, that's it.
No, me either.
Okay. Did I answer your questions, Vincent?
Yeah, I didn't have any specific questions. I wanted to just do a little more practice with this stuff because we haven't done too much at all.
Okay. So basically you have now like you have 2 classes every week.
Yeah.
How's the class going?
That's going Fine. We spend a lot of time, a very significant portion of the time deriving the formulas using calculus, and then very, very little time actually applying them.
Yeah, and the applying them part is the difficult part.
Exactly.
Yeah, you need to do more practice.
Yeah,
Yes,
that's exactly why I wanted to.
yeah, that's why we're trying the textbook problems.
Exactly.
Yeah.
Okay.
And just to make sure, so you said there's already a second submission open, because I'm going to have to correct my graphs as well.
Yes.
Fantastic.
I'm pretty sure I said I modified that. Yeah.
Okay.
Okay, then if there's no more questions, then I'll see you next Tuesday.
Sounds good.
Have a good day. Have a good week. Miss.
Thank you.
Okay.
Bye.
Bye. Goodbye.
Goodbye.